Hello, class. What we're going to go over is that molar mass worksheet, the bonus assignment for this lesson this week. Essentially, it's a very repetitive topic, but it's very foundational to continue on for the little bit of chemistry we'll use for thermodynamics next week. What the first problem is based on the following atomic masses. Determine the molecular or the molar mass of iron 3 chloride, FeCl3, in units of grams per mole, and then convert 1.5 moles of iron chloride to grams. And then convert 81.102 grams of iron chloride to moles. Have final answers rounded to 4 decimal places. The charts that we're going to have for these problem sets include all the elements that are inside that chemical formula, in this case iron and chlorine, and then their atomic masses in units of grams per mole. And those values are typically found on the periodic table of elements. Grams and moles, they're both units that describe the physical amount of something that you have. And it's similar to Fahrenheit and Celsius, where in some instances we might use Fahrenheit. In some instances, it may make more sense to use Celsius. In some instances, it's best to use Kelvin. Different temperature scales that all mean temperature. Well, in this case, when it comes to a certain amount, we can think of grams as what's more practical to actually measure with our hands or with ourselves, and whether through a spatula, a spoon, or whatnot to scoop it out. And moles is the unit system of amounts that's best for chemistry and in some certain instances of physics to go between different chemical and physical properties, such as between a certain amount of something that gets reacted to a certain amount that gets produced, or a certain amount of energy that gets produced. But in any case, first things first is to calculate the molar mass of iron 3 chloride. Now, in that case, what we're going to do is we're going to take the atomic mass of iron, 55.845, and multiply it by the number of iron atoms we have in our compound, which should be 1. And then we're going to take the atomic mass of chlorine, 35.453, and multiply it by the number of chlorine in our molecule, or compound, which would be 3 chlorines. Taking those two products and then adding their answers together, we're going to get 162.204 grams per mole of iron 3 chloride. And then the next step would just be, in our problem, we're told we have 1.5 moles of iron chloride. Well, taking that mole amount multiplied by the molar mass, 1.5 times 162.204 divided by 1. This gets our mole units to cancel, and we're just left with grams of iron 3 chloride. And therefore, our answer is 243.3060 grams. In other words, instead of having 1.5 moles, that is the same thing as about 243 grams of iron chloride. In the next scenario, if we're starting with 81.102 grams of iron chloride and we're asked to convert it to the mole system of amounts, well, just multiply by the reciprocal of the molar mass. 81.102 grams times 1 mole divided by 162.204 grams yields 0.5000 moles of iron 3 chloride. Problem 2 is doing the exact same thing but with water. So our formula is H2O. Calculating the molar mass of water, there are 2 hydrogens, and we're going to multiply them by the atomic mass of hydrogen, 1.008. And then we're going to take our 1 oxygen multiplied by the atomic mass of oxygen, which is roughly 16. The reason why I have a line under the O for oxygen is to indicate this is 1 oxygen and not to confuse it with the number 10. But doing this calculation, we get 18.016 grams per mole for water. The problem says, what if we start with 0.4 moles of water? What would that be in grams? Well, zero point 0.4 moles of H2O times 18.016 grams divided by 1 mole, that gets us to 7.2064 grams of water. If we're starting with 25.224 grams of water instead, that number times 1 mole over 18.016 grams gets us to 1.400 moles. Now, this problem here, problem 3, the molecule that we're working with is ammonia, NH3, which consists of 1 nitrogen and 3 hydrogens. Nitrogen has an atomic mass of 14.01. That multiplied by 1 nitrogen plus the atomic mass of hydrogen 1.008 times 3 hydrogens. This gets us to a molecular mass or a molar mass of 17.034 grams per mole for NH3. The problem tells us, what if we start with 1.65 moles of ammonia? Well, and we want to convert it to grams. We'll take that 1.65 moles times 17.034 grams divided by 1 mole. That comes out to 28.1061 grams of ammonia. And then the last part of problem 3, what if we are starting with 15.3306 grams of ammonia and asked to convert it to the mole system? Well, 15.3306 grams of ammonia times 1 mole of ammonia per 17.034 grams of ammonia, that comes out to 0.9000 moles of ammonia. Problem set 4 is just slightly a bigger problem, a slightly bigger formula. Let's say we're working with the molecule glucose, which consists of 6 carbons, 12 hydrogens, and 6 oxygens. Well, for each carbon, their atomic mass is roughly 12.01. The average atomic mass for hydrogen is 1.008, and then for oxygen, it's roughly 16. So doing our calculations like before, taking the atomic number of each element times the number of times that element shows up in our formula, and then adding up all these products together, gets us to 180.156 grams per mole for glucose. If we're starting with 0.5 moles of glucose, 0.5 times 180.156 grams divided by 1 mole gets us to 90.0780 grams of glucose. 36.0312 grams of glucose, if we're starting with that gram amount, times 1 mole divided by 180.156 grams, that gets us to 0.2000 moles of glucose, of C6H12O6. And lastly, for problem set 5, let's say we're working with calcium bicarbonate. Basically, what if we have an example where we have parentheses in our formula and then there's a subscript outside those parentheses? Well, in this case, Ca parenthesis HCO3 parenthesis 2, that 2 means that we have twice as many as whatever is in parentheses. So, in this case, let's look at how much of each element we have. We have 1 calcium, we have 2 times 1 hydrogens, 2 times 1 carbons, and 2 times 3 oxygens, or 6 oxygens. 40.078 times 1 calcium, plus 1.008 times 2 hydrogen, plus 12.01 times 2 carbon, plus 16 times 6 oxygen gets us to 162.114 grams per mole of calcium bicarbonate. And then if we're starting with 1.8500 moles of this compound, 1.85 moles times the molar mass of 162.114 over 1, that gets us to 299.9109 grams of calcium bicarbonate. If instead we're starting with a gram amount and asked to convert to moles, well, 154.0083 grams times 1 mole divided by 162.114 grams, that equals 0.9500 moles of calcium bicarbonate. So again, the only unique thing for this problem set was, what if we have a subscript outside of parentheses? Well, just treat it as multiplying the number of elements inside the parentheses. And then calculate your molar mass, as we've done before. And then it's just the same thing of converting moles to grams and grams to moles. Of course, that's it. Glad you're all here. Glad to have you all for class. And we'll use this topic in our next lesson next time. Peace.